options, developing solutions, helping America refine and enhance its deterrent posture.
Now, I think the thing I'm most proud of is the amount of teamwork that we managed to put together within our own organization, the amount of talent that we were able to put on this program, and the relations that we had with our customer and the customer's other associate contractors. It was a very tightly knit program, and without that same kind of closeness throughout the program, it would have been absolutely impossible to meet the goals and requirements that we did.
It's hard to pick any one particular item, but I know when we flew the first Minuteman III, I think that was an accomplishment. When we started the Minuteman III into the silo, and not only did we get them into the silos, but we beat every reliability incentive, every price incentive, and I can recall them delivering this huge check. They put it on they made a model of a big check that was presented to the corporation as our share of these incentives, and these were very proud moments that we had.
I guess I would have to say it was the first flight of Minuteman III, which was just about a 100% success. Prior to the time we had any flight failures, that first flight went like clockwork and deployed the objects in order, and we were sitting in the ops center in building 235 with a phone hookup to the Cape. To see it happen, and happen just the way it was supposed to happen, I thought was kind of the peak achievement of my career.
My personal idea of what was the greatest achievement, I thought was probably the Minuteman III silo reliability. Well, to make a long story short, not only did we achieve that, but we achieved, much greater than anybody ever imagined would be possible, and so I felt very good about that.
In a larger program sense, I think the success that led to the first flight on Peacekeeper in managing an organization, a very capable organization, but sorting out all the problems, paying the right either personal attention to them or having other teams pay attention to them, and ultimately then a program that led to a major underrun.
A lot of people have asked me what I'm most proud of on Peacekeeper, and I've thought a lot about it. And I think the thing that I'm most proud of are the performance of the people. Absolutely fantastic. So that's what I'm really proud of, is the ability to make the team work, to facilitate what had to be done without having to coerce anybody. When you get to heaven, if there's a Peacekeeper program, I'm going to be first in line for that job, brother. It was a real, real run.
In 1957, there was a competition, and the competition was for a 3-stage solid rocket engine missile called the Minuteman. We won that competition, and as I recall, we learned about that on the 20th of July, 1958. We saw the threat to the Navajo program of the ballistic missiles.
Well, the Minuteman I program was a major undertaking, as you know, in terms of doing things different than had been done before. And when we won the proposal, we discovered afterward that our proposal really didn't win, per se. What they found very attractive in it was a free rotor gyro, because that meant that opened the way for very long life on the gyros. And they liked our organization, where we had everything under one roof that could accomplish this integrated guidance and control system that they wanted. And this is the first time that anything this broad had ever been done.
To make the Minuteman missile a reality, the Air Force and industry embarked on a technical adventure that would focus talent, ingenuity, and scientific daring on the nation's first quick-reaction, solid-propellant intercontinental ballistic missile. And Autonetics was at the forefront of this development. Through historic film footage, let's relive the excitement at Autonetics when the first Minuteman was test launched.
Early in 1961, such an event occurred on a launching pad at Cape Canaveral. A Minuteman missile was being prepared for the first test firing. As the months of work and millions of man-hours of effort embodied in the missile approached the crucial moment of test, tension, anxiety, and hope mounted. Fond dreams and high expectations would soon be fulfilled or destroyed. While flight test personnel continued the launch preparations in the blockhouse, a telephone connection with the Cape relayed latest information to the Autonetics plant in Downey. As the countdown progressed, the growing tension was mirrored on the faces of all. And here it comes.
Climbing just beautifully. Did you hear the engine?
This was truly a shot heard around the world. A few days later, the people who built Minuteman participated in the excitement of the first flight through a closed-circuit TV rerun of the event. Minuteman's first flight was not only a successful liftoff, but each stage fired as planned, and the Autonetics guidance and control system successfully guided the Minuteman re-entry vehicle downrange to its target. At the time it entered the operational inventory, the Minuteman I had recorded the shortest development time from design to operation of any ballistic missile weapon system. No other weapon development had been as successful or as cost-effective.
Both the Polaris program and the Minuteman program were programs unparalleled except possibly for Apollo and the Manhattan Project in the history of the world.
800 missiles in large quantities. I think we hit as many as 60 a month at one time. And that was unheard of, and probably still unheard of with the complexity of the equipment that we turned out. But it was done.
And so we were a part of all that history. And it goes back to the excellent people that we had managed to attract under the leadership of Dutch Kennelberger and Lee Atwood into what was, after November 1955, the Autonetics Division.
With the germ of an idea, Autonetics scientists agreed there was no reason they couldn't consider the computer, which had come of age by then, to become the main element in the silo's command and control system. This was a revolutionary approach, so revolutionary in fact that the group was uncertain about how the Air Force would react to the idea. But it was a simple plan. All that was needed would be to revise the ground software program and redesign the computer to increase its memory capacity and functional capability. Once again, the guidance and control system bore the brunt of the new challenge. Because of the success of the guidance system's digital computer in Minuteman I, the Minuteman II digital computer was required to be expanded by a factor of 250% in order to take over the key message processing, secure coding, and monitoring and reporting functions previously performed by complex ground equipment in the silo.
It was clear that we probably could take some of that load off of the ground equipment by doing some more things in the missile computer.
The Minuteman program led in application of yet another advanced technology, radiation hardening, when Autonetics scientists and engineers were required almost overnight to find ways for increasing missile survivability against nuclear attack. Late in 1963, the Department of Defense and U.S. Air Force identified and defined a new classified system requirement, the incorporation of a nuclear hardening capability, which in essence would make the system relatively immune to the hostile environments of nuclear weapon detonations.
The Minuteman II became the first system to be fielded that was designed to withstand the nuclear hostile environment.
Accordingly, Minuteman II missiles with increased nuclear survivability were rapidly deployed, and a whole new technology was born. The first all-up configuration of the operational missile containing the new and revised requirements was flown successfully in May 1965, only 6 months after the last major segment of the new requirements had been placed on contract and 5 months before the planned operational deployment. The ultimate story of the Minuteman II Guidance and Control Program is one of unqualified success. The achievements in accuracy, weight, and in-flight reliability and improved operational reliability increased Minuteman II system effectiveness by 20% over requirements. A total of 805 Minuteman II guidance systems were produced by Autonetics, and after having overcome the design problems, Minuteman II had successfully utilized integrated circuits and leapfrogged into a completely new state-of-the-art technology called microelectronics.
At one time, probably in about 1964, we had more than half of all the integrated circuits being built in the world, to our knowledge, at least in the free world, coming into the Minuteman program.
I think it's well known that the development of the reliable electronics parts probably pushed the state of that art throughout the country by several years.
If it were not for the Minuteman program, there wouldn't be a Silicon Valley today.
By the time the Air Force had identified new strategic requirements beyond those of Minuteman II, the Autonetics technical team had already been at work designing a greatly improved and upgraded guidance and control package. During the 1964-1965 timeframe, a joint internal venture between North American Aviation's Autonetics and Rocketdyne divisions had developed a concept for a new post-boost control system. This system would provide a greatly improved method to precisely control the velocity and attitude of the reentry vehicle at the point of release from the missile. With this technology breakthrough came the next generation of Minuteman with a significantly increased mission capability. Major features of the new missile, which would become Minuteman III, were its new third stage, the post-boost propulsion system, and its multiple independently targetable reentry vehicle, or MIRV, system. With MIRVs, each Minuteman missile now could carry up to 3 warheads, each aimed at a separate target. But as in other new development efforts, this challenge again had placed Autonetics scientists in new territory.
The challenges presented by Minuteman III to the Autonetics team were many and varied, but there were 2 that stand out in my mind as somewhat unique. The post-boost propulsion subsystem and the deployment of multiple independently targeted reentry vehicles come to mind.
In 1966, the first engineering model computer for the Minuteman III missile was completed 2 months ahead of schedule. The microelectronic computer, the D37D, had twice the memory capacity plus other improvements over Minuteman II equipment. A new self-alignment technique developed by Autonetics provided automatic primary self-contained azimuth alignment, which eliminated a very long and complex alignment process of an external reference performed by Air Force teams. On August 16, 1968, the first Minuteman III research and development missile was launched from Cape Kennedy. The first unit of operational Minuteman III missiles were on station at the Strategic Air Command's Minot Air Force Base in North Dakota in July 1970.
So the Air Force at that time decided that they would have a flight test of just a Minuteman III with another wafer, which would be called the Missile Performance Measurement System, and it would include this AIRS IMU. And there was competition, I think about 73, and we won that competition to integrate this this new Draper Lab sort of advanced development IMU. And eventually that IMU was the one that was selected to provide the navigation capability for the MX, or Peacekeeper missile.
Well, in the early 70s, the Air Force had come up with a desire for a hard target kill missile. And what they had come upon was a very large missile, about 8 stories high, 8 feet in diameter, weighed a couple of 100,000 pounds. It had to have the hardness that was 3 times better than Minuteman and accuracy that was 3 times better than Minuteman. And they wanted to deliver 10 re-entry vehicles at the same time. It was a very, very powerful weapon that was meant to eliminate hard targets in the Soviet Union.
In September 1979, Autonetics began full-scale development of the MX, or Peacekeeper, missile guidance and control system.
We decided that on the computer portion of that, we were going to combine the computer and the flight control into one large box that was called the MECA, the Missile Electronics and Computer Assembly. It was the biggest thing we had ever built in the way of a hermetic box. Around 3 cubic feet, 180 pounds, had 15,000 electronic components in it, really big box. And of course, went into the MGCS, which was about 425 pounds. The drawer itself was very large. We had a little bit of trouble at the beginning in that we didn't think we were pulling engineering together well enough. We asked for a chief engineer, and the chief engineer turned out to be Tom Gunkel, who's probably about the best guy you ever could have selected for a job like that. And with Tom running things in engineering, the program really, really took off, and we did very, very well.
Specifically looking at the radiation-hard CMOS sauce, we got a development contract from the government. We called our project ABC, the Advanced Ballistic Computer, but actually that was the short name. The full name was Advanced Ballistic Computer, developed especially for guidance systems, went on through the whole alphabet. And to pronounce that, that was Project App Gedefke Jekyll Nachman Stuvitzes. But most people couldn't handle that, so we called it ABC. And what we pursued was very advanced packaging. In fact, some of the packaging ideas that we had then are just now coming into use. Pursued it with the government and our own IR&D. Ended up not using all the technology. The CMOS sauce we didn't use until a small missile. Some of the circumvention approaches we did use on Peacekeeper. But what it did was it made us the advanced computer supplier in the eyes of the customer. So when we wrote our proposal, and it was a competitive procurement, we knew we were playing into the right audience in terms of technology. With that computer development, we won the flight computer. The guidance integration job was actually competed separately, 2 different jobs, whereas in the past it had just been one job. We also won the guidance integration, which also was a competition. And then after we were awarded the 2 contracts, they were combined into a single contract, which was the Peacekeeper Development Program. Software was an area I think we surprised people. Did very well. But only because we worked at it. We had Monday afternoon meetings each week to go over all the software issues and problems, just to keep a focus on it, and it seemed to work. Parts, always a problem, but there too we made it. At the beginning of the program, we started off overrunning, and when I became chief engineer, we were still increasing the size of the overrun. And that peaked around $12 or $13 million. But by focusing on it, we turned it around and then ultimately underran the contract by $50 million across the 2 development programs.
I think some of the things that were challenging on the program, one of them was the massive amount of material, including subcontracts. 65% of the program was either subcontracted or supplier money. It was by far and away the biggest thing I think we've ever done in subcontracted or material effort, and that was a significant challenge because the subcontracts were important. Both memories were there, staging connectors, the umbilical group, in-flight coolant assembly, batteries. So there was a pretty good effort that was required to manage all that